All right, this is 3.4. We're talking about rational zeros. Rational zero theorem. Guys, rational zeros. Rational zeros. Everybody with me? Okay, we're going to talk about how to find all of the factors of something if it doesn't factor pretty and it's not a quadratic. Okay, the rational zero theorem is something that we call P over Q, where P, and I'm explaining this now, but I'll show you how this works in examples in a second. P is the constant of the function, and Q is the leading coefficient. What is the leading coefficient? What does that mean? The first number, the number in front. So if I had a polynomial that was like 2x to the fourth minus 7x to the third plus 6x squared minus x plus 10. Right? There's a polynomial. We're going to have something like this. You guys are going to factor it. Well, you guys can't group it because it doesn't group. And you can't use the quadratic formula. So you're going to have to use something called P over Q. So the way that you start P over Q is you say, okay, I'm going to take the constant, which is 10, and I'm going to put it over the leading coefficient, which is 2. And I get 5. And you're going to find all the factors of 5. And I'll show you this in a second. We're going to use synthetic division. The problems that we are going to deal with, all of the problems that we're going to deal with in our college algebra class, your leading coefficient is always just going to be 1. So your denominator is always going to be 1. We're not going to get into anything any more than that. So you would have something that says like x to the fourth, whatever. So the only thing when I tell you we have to do P over Q is you're going to be looking at the last number. But P over Q really means you take the constant and divide it by the leading coefficient. And then we're going to find all of the rational zeros. You'll see what that means in a second. So like this question, right? Find all the rational zeros. Finding the zeros means to factor. So you guys would look at this and say, okay, x cubed minus 3x plus 2 equals 0. Is this a quadratic that I could just plug this into the quadratic formula? No. Can I factor this? Yeah. No. If it was x squared, I could. But do we have x times what is going to give me x cubed?
X squared times x.
Right, so we don't factor like that. We don't have a GCF we can take out. So when something doesn't factor, this is when we use our rational zero theorem, our P over Q. I'm going to just call it P over Q. What you guys are going to do is you're going to take the last number, the constant. So we're going to write down 2. And you always have to account for positive factors and negative. So let's just write plus minus 2. So what are all the factors of positive and negative 2? What times what gives you 2? 1 and 2, okay? So you have plus or minus 1 or 2. Now what you guys do is synthetic division. We're just going to keep doing synthetic division until we get a remainder of what that says it's a factor? 1 times 2, yep. So I'm going to say, okay, let me try 1. Let's use synthetic division and see if 1 works. So I'm going to say 1. My coefficients are 1, then what? 0, negative 3, and 2, correct? Where did I get those numbers from? The coefficient of the minus. So bring this down. Bring down your 1. 1 times 1 is 1. 0 plus 1 is 1, right? 1 times 1 is 1. Negative 3 plus 1 is negative 2. What's negative 2 times 1? Negative 2. What's 2 and negative 2? What did you guys just prove? That one of your zeros, x equals what? 1. You just found out that x equals 1. This didn't factor pretty or anything like that. You had to use synthetic division. Yes, ma'am. I just started with the factors that I pulled out here. I started with positive 1. If positive 1 works, then you're good.
Those factors.
Yeah. It's the factors of the last number. 1 times 2 is 2.
Oh.
That's okay. Good question. So now, guys, how many answers should I have for this problem?
3.
I should have 3. A lot of times when you do P over Q, you use synthetic division, you get your answer, and then you have to write your resulting polynomial. How would I write my resulting polynomial here? This is x what? Squared. This is x. This is my constant, my remainder. So I'm left with x squared plus x minus 2 equals 0. Can I factor that more?
Yeah.
Every time you do this, you'll be able to factor a little bit more to find all the zeros. What are the factors of negative 2 that multiply to give me negative 2 but add to give me 1? X minus 1 and x plus 2. So here I get x equals positive 1, and here I get x equals negative 2. So what are the rational zeros? What are your zeros for this function? X equals 1, x equals 1, and x equals negative 2. If I asked you, is there multiplicity, what would you tell me? Yes. How many times? Twice. Where? At x equals 1. Good, Sarah. Okay, let's go to the next one. This is exactly what I just told you. You're going to list the possible zeros, you're going to do your synthetic division, and you just keep dividing. The way that you know something is a factor, is a zero, is when your remainder is what? 0. Okay, so let's do these 3 examples, then we're done. Look at this first question, number 1. I look at this. The first thing I'm going to do is say, is there a GCF? Is there a number or a letter that I can take out of all of these? No.
What? Oh, yeah.
What do they all have in common? Nothing, right? Can I group this? Do you guys know how to factor where we group like this? No, we only group when there's 4 terms. So when you can't factor, you can't group, you can't take a GCF out, we have to do our rational zeros, rational root theorem. We have to do our P over Q. That's where we look at the last number. What are the factors of 8? What times what gives me 8? Okay, 4 and 2, and what else? So plus or minus 1, 2, 4, and 8. We're just going to try synthetic division with those numbers until we get our remainder to be 0. Now, some people are going to say, do I have to always start with 1? You don't have to. You could start with negative 4, see if that works. Some people are then like, well, then fine, I want to try 2. I don't like to do that. I like to always start with positive 1. If that doesn't work, I go to negative 1. Then I go to the next number, positive and negative. I like to do things in order, but that's just me. So the first number I'm going to try is positive 1. Let's see if it works. Coefficients of your polynomial are 1, 1, negative 6, negative 4, and 8, right? Okay, synthetic division, bring down your 1. Go to the corner. 1 times 1 is?
1.
And 1 plus 1 is? 2. Go to the corner. 2 times 1 is? 2. Negative 6 plus 2 is? Negative 4. Negative 4 times 1 is? Negative 4. Negative 4, negative 4 is? Negative 8. Negative 8 times 1 is? Negative 8. And 8 and negative 8 is? So what'd you guys just prove? That's a 0. That's a factor. So I'm going to write, okay, one of my factors is x equals 1. How many answers should I have? 4. So now you have to write your resulting polynomial. This started off as x to the 4th. So my answer is x cubed, x squared, x, constant, remainder, right? Okay, so I have x cubed plus 2x squared minus 4x minus 8 equals 0. So now what Sarah just asked is, well, could I do synthetic division again? Right? You're going to do factors of negative 8? Absolutely. But I would always try, after you get one of your zeros to work, try to factor with what you have left over. I have 4 terms. What do we do with 4 terms? We group. Okay, so let's try and group this. What can I take out of the first group? So take out x squared, and you're left with x plus 2. What could I take out of the next one? Negative 4, and I'm left with? Ooh, that worked out nicely, didn't it? What's your new GCF here? Take out the x plus 2. What do you have left over? X squared minus 4 equals 0. Can you factor that more?
Yep.
Sure can. X plus 2 in the front here. This becomes x plus 2, x minus 2, all equals 0. So now I say x equals negative 2, x equals negative 2, and x equals what? Positive 2. So I have 3 answers there. I had 1 up here, right, to give me all 4 of my answers.
Would you be able to put x equals plus or minus 2 and then put x equals negative 2? To save time.
You can write, Oh, I see what you're saying. Yeah, that'd be fine. But how many answers do we have here? We have 4. We have x equals 1. And then we have x equals -2. How many times? 2 times. So that means there's multiplicity. Good. See? All of this is nothing new. Nothing new. Look at your next one. Yes, ma'am. I'm just repeating that since we just did it. Okay, I have 4 terms. I don't see a GCF, but since I do have 4 terms, what should I do before I just jump into P over Q? Let's see if we can group it. If I group the first 2 and I group the second 2, I can take out an x squared, right? And I'm left with x plus 5. What can I take out of the second one? -2, and I'm left with x plus 12. Does that help me at all? All right, it doesn't factor, guys. So what do we have to do? P over Q. Where do I look for P over Q? Question.
Even if it could factor.
Notice, guys, what's the leading coefficient? Just 1, all right? Ours are always going to be just 1. We don't have to worry about dividing anything. Now, factors of 24. There's a lot of them. 1 and 24, right? So I have plus or minus 1. Does 2 go into 24? Yep. Does 3? Yeah. Does 4? Yeah. Does 6? Does 8? Does 12? And does 24? Yeah. All right. There's a lot there. I understand that. So some of you are going to say, fine, well, I want to start with -6. Okay, fine. Do what you want. I think it's best to start with what number? 1. And if 1 doesn't work, go to what? No. -1. And then if that doesn't work, go to 2. And then -2. And then? Okay. Seriously doubt you're going to have to go through a list of like 10 before you get there, but we'll see. So write out your coefficients. 1, +5, -2, -24. You guys with me? All right, bring down the 1. 1 times 1 is 1. 5 plus 1 is 6. 6 times 1 is 6. -2 and 6 is 4. 4 times 1 is this going to give me 0? Okay, so just go to the next one. Try -1. 1, 5, -2, -24. Bring down the 1. 1 times -1 is -1. 5 and -1 is 4. 4 and -1 is -4. -2 and -4 is -6. Is this going to give me 0? So then go to what? Let's try 2. 1, 5, -2, -24. Bring down the 1. 1 times 2 is 2, and 5 plus 2 is 7. 7 times 2 is 14. -2 and 14 is 12. 12 times 2 is what? What's -24 and a +24? 0. What'd you guys just show me? X equals 2. I know that. X equals 2. There's one of my zeros. How many zeros should I have? 3. So I have 2 more left. Well, remainder, constant, x squared, right? Mariana, perfect. We go backwards. So this is x squared plus 7x plus 12 equals 0. Can we factor this?
Yeah.
Factors of 12 that multiply to give me 12 but add to give me 7.
3 and 4.
X plus 3, x plus 4. Good. So x equals -3 and x equals -4. You guys see that? So if somebody started out in the middle of our factors and you said, I want to start out with 3, see if 3 works. And it didn't. And then you went to -3 with your synthetic division. Would that have worked?
No. Oh, yeah.
Yeah, because it's one of your zeros. So if you don't start the same place I do, that's okay. But all 3 of these are zeros of your function. Yes, ma'am. All right. All right. Is this going to group? No. So I have to look at the last number, which is 60. There's lots of factors of 60, yes? Okay, so let's just go through. Come on, right with me. Does 1 go into 60? Yep. How about 2? Yep. How about 3? Yep. How about 4? Yep. How about 5? Yep. How about 6? Yep. 7? Yay. 8? No. 9? No. 10? Yep. 11? No. 12? 13? 14? 15?
Yes.
16?
No.
17? 18? 19? 20?
Yes.
Yep. 30?
Yes.
60?
Yes.
Okay.
Wow.
Wow.
All down the test, like,
Adam, am I going to give you one where you have to do synthetic division 100 times? No. I mean, 60 is a large number. I understand that. But we're probably not going to have to synthetically divide 60 times. Probably not. What am I going to start with? 1. What are you guys going to start with? Good. Hopefully. So I have 1, negative 12, 47, and negative 60. Do you think 1 or negative 1 is going to work? Probably not, but let's just do it real quick. Bring down your 1. 1 times 1 is 1. Negative 12 and 1 is negative 11. Negative 11 times 1 is negative 11. Negative 47 and negative 11. Positive 36. Is this going to work?
No.
Okay, just go ahead and stop. Now go to negative 1 real quick. 1, negative 12, 47, and negative 60. Okay. So 1 times negative 1 is negative 1. Negative 12 and negative 1 is negative 13. Negative 13 and negative 1 is positive 13. What's 47 and 13?
60.
60. Huh. What's 60 times negative 1?
Negative 60.
Does this one work?
No.
Okay. Let's go to 2. 1, negative 12, 47, negative 60. 1 times 2 is 2. Negative 12 and 2 is negative 10. Negative 10 and 2 is negative 20. 47 and negative 20. 27. Is this going to work? Okay. 1, negative 12, 47, negative 60. Perseverance, guys. 1 times negative 2. Negative 2. Negative 12 and negative 2. Negative 14. What's negative 14 and negative 2? 28. Positive 28. What's 27 and 28?
21.
Sorry, 47 and 28. Is this one going to work?
19.
Yes or no? Okay, let's try 3. 1, negative 12, 47, negative 60. 1 times 3 is? Negative 12 and 3 is? Negative 9. Negative 9 and 3 is? Negative 27. What's 47 and negative 27? 20. What's 20 times 3? Woohoo! What's negative 60 and positive 60? I heard you say it. What's negative 60 and positive 60? 0. So what did we just prove? X equals 3. What a relief. You might, Riley. Don't pin me down. Is that going to be just... I'm not going to give you one that the factors of 1 and 2. No, it's not. It took us like 3 minutes. Okay, here we go. What am I left with? X squared minus 9x plus 20 equals 0. Can I factor this? Yeah. What times what gives you a positive 20 when you multiply, but a negative 9 when you add? X minus 5 and x minus 4. So x equals 5 and x equals 4. There are your 3 zeros. Very good.
Use a quadratic.
So that's it, guys. That's all P over Q is. It's when you look, the first thing you should always look to do to see if you can factor something. If you're finding the zeros, that says what does x equal? So look to see if you can factor. If something factors, fantastic, do it that way. But if it doesn't, here's another method to help you do that. So when we come back after Thanksgiving, I'm going to give you guys some practice on this. We're going to learn 3.5, and then we'll be ready for our last test. I will have your quizzes back to you. Sound good? Okay.